So, good day, grade 8 students, Happy Science High School. So, we're going to continue our second problem for our lesson for today, which is about chords of circles, one of the line segments that we can find in the circles. Again, we have we have the tangent, and then the secant, and then lastly, we have the chord, our lesson for today. And this is the second problem. So, we have here Dexter on his free time fidgeted with the old CD that his mom kept in their closet. So given that they were looking for scratches on the CD, he tried to measure them. Okay, so there you go, Dexter did that. And on the CD given below, he only measured RS. Okay, so he only measured RS, which is equal to, so this line segment over here is equal to 6 inches, and the measurement of OM is equal to 5 inches. Okay, and the measurement of ON for this one is equal to 4 inches. He would like to know what the measure of the scratch PQ of the scratch is going to be. So what's the length of scratch PQ for this problem? Okay, so guys, we're going to be using two chord theorems here. Okay, so the first chord theorem that we can use, is that if we have perpendicular lines, there are perpendicular lines here. If we have diameters that are perpendicular from the center, then for this problem we have bisected the chord and the arc. Okay, for this problem we have two components here. We have chord RS and then we have chord PQ. Okay, but we don't really need, I mentioned the word arc, okay, but we don't really need the arc for this one. There is an arc RS and an arc PQ, but since we're only looking for the measurement of PQ here, we don't really need the arc. So according to this theorem about chords, the chord here is going to be bisected. Okay, and since RS, according to this problem, RS, okay, let's write that down. So RS is equal to 6 inches. So therefore, the measurement of MS for this problem, MS is just going to be 1/2 of RS. And that should give you 1/2 of 6, which is going to give you 3 inches. This is the measurement of MS. Okay, so if this is 3 inches, okay, we can draw a line here, KO, that connects point O to S, so that's going to give us a line segment OS, and this should give us a right triangle over here. Okay, so what's the second theorem that we can use for this one? We can use another theorem. So if we have two chords that have the same distance, okay, so same distance from the center, then they have congruent segments. Okay, so let's say for example this is going to be 5 and this is going to be 5 as well. Let's say for example this is 5, then the measurement of RS is going to be equal to the measurement of PQ. Since we know the value of RS is equal to 6 inches, therefore PQ must be equal to 6 inches as well. But that's not the case. If you look at here closely, so this is 5 inches, okay, for this one. The measurement of this line here is 5 inches, and the measurement of this line here is equal to 4 inches. So therefore, we cannot apply this second chord theorem. It looks like we can apply it for this problem, but it turns out that we won't be able to use it, okay, for this one. Okay, so therefore, okay, we're going to stick with the given that we have here. To solve for the measurement of line and NQ here, we would need to find the measurement of NQ, because NQ is just going to be equal to PN. And if we get PN and NQ, we can get the total measurement of PQ. Okay, and to do that, we need to draw right triangles. Okay, so for the first one, we drew the first right triangle here. Okay, so if we're going to write it over here, so we have here, this is the right angle. Okay, and the hypotenuse is missing. And then we have here the height is gonna be 6. Okay, the height is equal to 6. No, it's equal to it's equal to 5. Okay, so that's gonna be OM. So that's equal to 5. And then the side measurement over here, that's equal to 3. To solve for the height, okay guys, so to solve for the height, this will give us, we should use the Pythagorean Theorem. So if a squared plus b squared is equal to c squared. So therefore this is going to give us 3 squared plus 5 squared is equal to c squared. And that should give us 9 plus 25 is equal to c squared. That should give us 36 is equal to c squared. And therefore, okay, let's just check 25 plus 9. Okay, so that's 34. Okay, so therefore the value of c, of the hypotenuse over here, okay, so if we take the square root of that, of these two values, therefore c is just equal to square root of 34. Okay, therefore the hypotenuse over here is just equal to square root of 34. And why is that important? Okay, so to get the value, okay, if we got here square root of 34 for this problem, we can get the value of OQ as well for this problem, because we have 4 over here. Okay, right? So this is 4. The measurement of ON, of this side measurement, okay, so that's equal to 4 inches. And what we can see here, guys, OS and OQ, what commonality do they have? What property of a circle, or what part of the circle are they? They are both radii of a circle. So OS is a radius, and OQ is also a radius. So therefore they're both a radii, of the circle, and therefore they should be congruent to each other. They should be the same. OS is equal to OQ. Okay, and therefore if this is square root of 34, therefore the hypotenuse, or the radius over here, should also be equal to square root of 34. And now we can solve for the second right triangle. So what's going to be the measurement of the second right triangle over here? We have here, if this was 5 for our first right triangle over here that we flipped, this one we won't have to flip it anymore. So this is going to be 4, and the hypotenuse is going to be equal to square root of 34. We just need to find the side measurement, the one that we're looking for, the measurement of NQ. So that should give us a squared plus b squared is equal to c squared. And the value of a is just going to be 4 squared plus b squared is equal to the square root of 34 squared. And that's just going to give us 16 plus b squared is equal to 34. Therefore, b squared is equal to 34 minus 16. And what's 34 minus 16, guys? So that should give us 18. B squared is equal to 18. And taking the square root of both sides, so that should give us a factor of 9 times 2, and therefore that should give us 3 square root of 2. Okay, so therefore the measurement of NQ is equal to 3 square root of 2. Okay, and if NQ is equal to 3 square root of 2, and that line segment over there, NQ, this one, okay, is equal, NQ is equal to PN. Okay, therefore PQ is just going to be equal to PN plus NQ. And since they are both 3 square root of 2, we can just multiply both sides. We can just multiply 3 square root of 2 by 2, because that's going to be 3 square root of 2 plus 3 square root of 2. So therefore the value of PQ, guys, for this problem, so that's just equal to 6 square root of 2 inches. And what have you noticed, guys? The line segment PQ over here is not congruent with the line segment RS. RS is just equal to 6 inches, with the distance, okay, from the center being 5 inches. Okay, that's the distance from the center. And then we have here line segment PQ. Its chord is equal to 6 square root of 2, and its distance from the center of the circle, or of the disc of the CD, is only 4 inches. So there you go. You see the relationship between the distances of the chords from the center. It changes the value of the chords. Those are very important relationships, and I hope you learned a lot from this video. And that's how we solved it for this problem.